Today we'll study about convection via this experiment. In order to do this experiment, we need a circular sheet of paper, a scissor, a candle and a matchstick and one stand. I have made the stand via a pipe. You can use anything, a stick, a chopstick, whatever you find at home. Now let's start this by making a circular circle on this sheet. Now let's cut this circle. After cutting the paper in this spiral manner, place this spiral as it is on the top of this stand. Now light both the candles. Let's see what happens now. As you can see, the paper is spinning on its own. Isn't it cool? Now why does this happen? It is because of convection. Convection in simple term means movement in a gas or liquid in which the warmer parts move up and the cooler parts move down. In this case, when air above this candle is heated, it expands and its molecules spread out away from each other. In other words, hot air is less dense than cool air. This means that hot air will rise above cool air, and that's exactly what you're seeing with this spinning paper. As the hot air rises up, the cooler air flows in to replace it. But then the cool air gets heated by the candle, and the whole thing repeats. This cycle of moving air is called a convection current. Convection is used by us every day, like for example in boiling water. This is the most common example of convection. In this, when the water is heated in a kettle, thermal expansion takes place. The lower layer of the water, which is hotter, becomes less dense and moves upward. The cooler or the upper layer of the water falls below and gets heated as well. The process is repeated until the entire water in the kettle is heated up. Another such example of convection is in air conditioner. Most of us use AC every single day, but do you know how it works? When we turn on AC, it releases cool air. This released air falls below the warm air and quickly fills up the room because it's denser. The warm air, which is less dense, rises above the cool air and it's sucked into the compressor of the air conditioner. Therefore, a compressor always gives out warm air. The continuous sucking out of warm air while filling the room with cooler air sets up a convection current. The human body continuously produces warm air as well as any ongoing activities in the room. As long as the air conditioner is turned on, this warm air will always be replaced by cool air. So now you know how an air conditioner works. Let's discuss one more example of hot air balloon. Have you ever wondered why a hot air balloon rises up so high in the sky? It is because of the heat source at the bottom of the balloon heats the air molecule around the flame, causing them to move upwards. The hot air which moves upward gets trapped inside the balloon, causing the balloon to rise up too. The cool air is pushed downward where it is also heated and it rises too to further push the balloon upward. Through this convection process, the balloon keeps moving in the upward direction. Now, what do you do to land the hot air balloon? To land, a large mass of hot air is released. By doing so, cool air replaces the hot air and the balloon lowers gradually until it reaches ground level. Hello guys, today we'll study about osmosis. Osmosis is a process by which molecules pass through a semi-permeable membrane from a less concentrated solution to a more concentrated solution. So let's see this process ourselves by using an egg. In order to do this experiment, we need vinegar, a spoon, green food color, glass and honey. Let's begin this experiment. Let's put this egg into the glass slowly. Make sure you don't break it. Then pour this vinegar into the glass. This vinegar will break the outer shell of the egg. We'll keep this aside for 24 hours and then check back on it. As you can see, after 5 minutes, the vinegar is starting to do its work and the outer eggshell is starting to dissolve. The oxygen molecules clinging to the eggshell will make the egg rise upwards. Now, why are we using vinegar in order to dissolve this eggshell? Vinegar is an acid. Eggshells are made up of calcium carbonate. When you soak an egg in vinegar, the eggshell will absorb the acid and break down or dissolve. The calcium carbonate will become carbon dioxide gas, which will go into the air. Now what will be left is the soft tissue that lined the inside of the eggshell, thus making it semi-permeable. We want it to be semi-permeable because it will only allow certain molecules to pass through it. Now after 24 hours, you can see that water molecules from vinegar has passed into it and the size of the egg is slightly increased than the earlier. We'll see this clearer once we rinse the egg. It's been 24 hours. Now we'll drain out the excess vinegar. Rinse this egg. This is how the egg will look after 24 hours. As you can see, the vinegar has completely dissolved the outer shell of the egg. Now we'll keep this egg in this glass very gently. Pour this honey into the glass. And keep this for another 24 hours. 24 hours now, so let's see what has happened to our egg. We'll gently remove the egg using a spoon. Be very careful as to not to break the egg. As you can see now, the egg has completely lost its hard shell and has shrunk in size. Now why did this happen? It's because of osmosis. The water molecule or the egg liquid moved from the egg to the honey solution. This is what osmosis is, wherein a solvent will move from a low concentrated solution to a high concentrated solution. In this case, sugar was a high concentrated solution. Now let's see the reverse of this by putting this egg into a colored liquid solution. Now take a glass of water and add a food color in it. I have taken green color. Stir the water. Now place the shrunken egg into the water. Now we'll keep this aside again for 24 hours and see what happens. It's been 24 hours. Now let's check what has happened to our egg. Gently remove the egg. As you can see, the egg has grown back to its original size and is green in color. This is because osmosis has taken place in this. Earlier the egg was shrunk. Now when we put this into this solution, the water has moved from the glass into the egg. That is passing off the water molecules through a semi-permeable membrane into the egg. This is what osmosis is. So today we learned about osmosis. By osmosis, you can increase an egg's size or shrink it. This was the original egg we used, and then we put that into vinegar. So this is the egg without its shell. When we place this egg into the honey solution, it shrunk because the solvent moved out of it into the honey, and this increased in size because the water moved into it. So this is what osmosis is. Hans Christian Ørsted is the physicist who discovered electromagnetism. During a lecture demonstration on April 21, 1820, while setting up his apparatus, Ørsted noticed that when he turned on an electric current by connecting the wire to both the ends of the battery, a compass needle held nearby deflected away from magnetic north where it normally pointed. He then published this into an article, and electromagnetic theory was then developed. Ørsted is also used as a unit of measuring magnetic field strength. Hello guys, today we'll study about electromagnets and build one ourselves. So in order to build an electromagnet, we need a battery, a copper wire, some pins and one nail. Let's begin now. This wrapping of wire will take a few minutes because you have to do it very neatly and not in any haphazard manner. Just take your time and do it slowly. Now I've finished wrapping this copper wire around the nail and I've attached this battery's wire to it. Before that, let's see if this attracts the blade pieces. Now the nail by itself will not act as a magnet. Let's see what happens when you connect it to a battery. We have attached this wire to this battery. Before we do this experiment, it is important to remember that electricity can create a magnetic field. I know this sounds strange because we are used to getting magnetic field from magnets itself. But when a wire is running through an electric current, it can create a magnetic field. When you put an iron through a copper wire, the iron becomes a bar magnet. Now let's check if this is true. As you can see, the nail has attracted this blade piece, so it has turned into a temporary magnet. Now this has comparatively weaker power. If you want a higher electromagnetic power, then you have to increase the electric current running through the battery, or you can increase the number of coils running through the iron nail. So today we learned what an electromagnet is. We use electromagnets every day in our life. For example, in electric doorbells, electric locks, loudspeakers, and earphones. Let's discuss what happens in electric doorbells. This is an image of inner circuit of electric bell. Before we understand how this works, you should remember that an electromagnet acts as a temporary magnet. That means it will only act as a magnet as long as an electric current flows through it. So in this case, A is an electromagnet. So when the D switch is on, the current will flow through A and it becomes an electromagnet. Then it momentarily attracts B toward it, and at the ball at the end of it hits the bell, producing the sound. As B was attracted to A, the current through the circuit got cut off. That in turn made it lose its magnetism. Then B was released from A to be back in contact with C. The circuit is now complete again and the current starts flowing through it, repeating the above sequence of events. As a result, we get a continuous ringing as long as the switch remains on. Let's understand this by this following animation. As you can see here, the bell is continuously ringing because the switch is on. When the switch is turned off, the circuit will break and the ring will stop. This is how an electromagnet works. Thank you for watching.